Assalamualaikum and hi. My name is Nurul Nordieyana binti MD AZAN S55824. So today I would like to present to you the ocean iron fertilization, or also known as OIF. For the part 1 understanding, we will go first for the definitions. So, iron fertilization is the stimulation of phytoplankton growth in the upper layer of the sea by the addition of iron, and it can occur artificially or naturally. Martin come to this finding by belief that dust input are usually considered as major natural iron source for ocean fertilization, and Martin hypothesized that during LGM, which is large glacier maximum, the increasing amount of dust input will relieve limitation of iron and substantially enhance the biological pump, particularly in southern ocean. The main objective from this experiment are to draw down the atmospheric carbon dioxide (CO2) by adding nutrients such as iron, nitrogen, and phosphorus compound. Besides, Martin target to stimulate phytoplankton growth by the accumulation of the nutrients. Lastly, to lower down the carbon dioxide level by exporting them to the deep ocean by the biological pump. For your information, the biological pump is often described as a single fusion process in which organic matter is produced by phytoplankton during photosynthesis in surface water will quickly transported into deep waters. There are 4 exact locations for ocean iron fertilization experiment, which are subarctic North Pacific, equatorial Pacific, Southern Ocean, and subtropical North Atlantic. For subarctic North Pacific, equatorial Pacific, Southern Ocean, they are well known as HNCL region, which is high nutrient and low chlorophyll region, which is the amount of nitrate approximately more than 10 micrometer. And for the subtropical North Atlantic, they are known as LNLC region, which is low nutrient, low chlorophyll region. So the amount of nitrate approximately lower than 1 micrometer. One could relate between high iron and reduced carbon in the atmosphere and vice versa in the context of increasing global, social, political, and economic concerns associated with rapid climate change. It is necessary to examine the validity and usefulness of the OIF experimentation as a climate change mitigation strategy. Furthermore, OIF experiments have provided insight into the structure and function of pelagic ecosystem that cannot be acquired from observational cruise alone. Non-OIF observation provide an assortment of snapshots from which only an incomplete image of the process involved can be rendered. There are total 13 artificial ocean iron fertilization experiments, which are Iron X1, Iron X2, Sorry, AZAN X, Seed 1, Series, Sulfur S, Sulfur N, Seeds 2, Effect, Siege, Seeds, Papa, and Lohafect. There are several limitations that have been classified as potential causes for the unsuccessful finding of the study. Firstly, for Iron X1, the limitations are subduction of the fertilized splash, single iron addition, insufficient experimental periods to observe the full phase of biogeochemical response from the onset to termination after iron addition, micro or macro limitation. For the iron experiment 2, the limitations are not export flux measurement in the deep ocean, insufficient experimental duration. For solidity and sulfates S, the limitation is insufficient experimental duration. Following for NSAN X, the limitation is the light limitation by storms, insufficient experimental duration. For sulfate N, the limitation is entrance of dissolved silicate into the fertilized splash by physical mixings, no direct measurement of export, flux with sediment traps. For Sage, the limitation is high dilution rate by small splash size. For Seeds 1, the limitation is single ion addition and insufficient experimental duration. According to Ocean Iron Fertilization Journal, there's a total of 13 experiments being done in order to do research on the iron fertilization. Generally, not all experiments fulfill their main goal, which are to remove carbon from the atmosphere and increase the amount of carbon sequestration Carbon export has no significant changes have been detected except for Southern Ocean European Iron Fertilization Experiment (AFEC). Initially, almost all of the experiment was successful at first, since the growth of plankton have been recorded, but it slowly decreased due to fewer constraints such as rapid recycling of organic matter due to dominance phytoplankton and grazing that lead to rapid recycling of organic matter in the mixed layer. In fact, one of the 13 experiments successfully recorded the downward carbon flux into deep water in the South Ocean in the Soiri experiment. Apart from that, there's a few concerns that arise regardless of the environmental side effect, which is the production of greenhouse gases such as nitrous oxide (N2O) and methane (CS4). Plus, toxic algal bloom such as Pseudomonas. This side effect will head up to negative climate change and ecosystem changes. There should be some improvement in the experiment in the future. So there's 5 things to be considered to ensure the future experiment achieve its main goal. For the first, experiments are conducted in the center of an airy structure when grazing pressure is low during the early summer. So second, shipboard observations are made during a minimum of approximately 40 days with multiple iron injection, at least for 2 or 3 times. So third, the iron fertilized batch is traced using both physical, such as drifting buoy, and biogeochemical, such as SF6, and online PCO2 measurement tracer. Fourth is the NBST, which is naturally buoyant sediment trap system and water column, are employed at 2 depth, which is below the in-situ MLD, which is mixed layer depth, and the winter MLD. Fifth, the side effect on marine ecosystem, including decline in oxygen content and production of climate-relevant gases such as N2O and toxic domoic acid, are monitored using optical sensor-equipped autonomous moor profiler and autonomous BINTI vehicle. That's all from me. Thank you.